Hello everyone, this is Tejas Raj from Sri Venkateswara College of Engineering from the course of Data Science, and I am here to discuss about browser history management in data structure and algorithm. This actually explores the fundamental data structure and algorithm, the power, the management of browser history, from efficient storage and retrieval to seamless and privacy consideration. Uncover the inner working, the enable the smooth navigations of your digital footprint. So let's move on. Now we'll see the overview of browser history. Keeps tracks of websites and pages you are visited, allows you to revisit previous location with easy way. So let's move on with another. Now we'll see data structures for browser history that comes under linked list and trees, which we can do in linked list and also in trees, which is stores visited pages in a linear sequence, enabling efficient forward backward navigations. Then in trees, organize history into a hierarchical structure, making it easy to explore related pages. So let's move on. Now we'll discuss about efficient storage and retrieval. The first thing is incremental indexing, which is optimize history storage by only recording changes, reducing independent data, then catching and prefetching, anticipate user needs and preload relevant history data for faster access. So let's move on. Now we'll see about the algorithm for history and navigation, which is of back and forward. We can track it. Then efficient traversal, the history tree to revisit previous pages. As you can see in URL, which you can go forward and also backward. If you visit any of the website, you can go forward and also backward. And also you can search and filtering, which you can see now. Equally locate specific pages or filter history by date, sites or keywords. Then predictive suggestions, leverage machine learning to anticipate and suggest relevant history items. Then we'll see about backup strategies, which cross device sync. Ensure a seamless browsing experience by sensing history across all of your device. Then secure backups will get a security or protection for the browsing history. As we can see, protect your browsing history with robust backup solutions to prevent data loss. So let's move on. Now we are moving to privacy and security consideration, which is implement strong encryption to safeguard sensitive browsing data, then offer granular control over history, visibility, and sharing. So let's move on. At the final thing, we can see the emerging trends and future directions, which is voice enabled history and intelligent recommendation and immersive browsing, which we can see seamless browsing history manages language commands. Also it can manages the intelligent recommendations, AI driven suggestions to surface relevant history items based on your context. So these are the emerging trends in the futures which we can see. So thank you everyone for watching this video, and hope it was helpful even in the code which I have done, and it will be very helpful. Thank you. We were discussing about browser history management, and we'll see how in Google Chrome will give the answer, and we'll get to know. If you want to view your search history to delete or manage certain websites, you can easily do by navigating to your browser history settings. And we'll see, and we'll do some code now about the browser history. The first thing is hash include str.h. This is the header file. Hash include stdlib.h. Then hash include string.h. Then we'll see about hash define max of 100, which is the maximum size of the stack that can hold. Then we'll see type def, which is struct, defines the stack structure actually. So a 2D array to store the up to max URLs, with each URL having a maximum length of 100 characters it can take. Then int top tracks the index of the top most element in this stack. Then we'll end the stack with the syntax. Then we'll create a function which is void push with stack pointer stack comma character star URL. Then as we'll check if the stack is not full by stack which points to the top of lesser than max minus 1. Then increments the top index and copies the URL into the stack's data array using strcpy, as you can see now. If the stack is full, prints an error message. Then comma URL. Then we'll see the pop operation, else we'll see the error message we can give, like stack overflow. Backslash n for the new line, and we go for pop operation, which will create a character star pop, which it will return pointer value, so we'll give a star pop. Then we'll see, we'll check if the stack is not empty, which stack is pointing to top, greater than equal to 0, then returns the topmost URL and decrements the top index. So I didn't give the return value, I'll give now. Then if the stack is empty, prints an error message and returns null. Then we can see about else will give an error message again, stack underflow, then again \n for the new line, then we'll give the return value which is null. Then we'll give type def for browser history structure. Like we'll create type def struct browser history, which consists of stack to store the URL visited before the current page, which is backstack we'll be using. Then forward stack we are using to stack to store URLs visited after going back. So you can know that which consists of unread, which a character current, which current stores the URL of the currently displayed page. Then we can create by void, which it sets the top of the both stack to -1, which is empty, which denotes it is empty. Then sets the current page to the no page visited, as you can see now, which I will do now. Browser, which is pointing to backstack dot top is equal to -1. Then browser, which points to forward stack dot top equal to -1. Then strcpy, which we can copy browser, which points to current, then no page visited. Now we'll create void display which browser history, which consists of browser, character URL, printf current page, %s\n for the new line, comma browser, which points to current. Then strcmpy for browser, which points to the current, comma URL. Then we'll give printf visited back history. For int I is equal to 0, I is lesser than equal to browsers
which points to current, browser which points to backstack, printf moved back which actually checks if the backstack is empty, pushes the current page onto the forward stack. Then we'll give int main, which browser's history, which we can initialize the browser history, then visits several pages, then performs back and forward navigations also, then display the current page and history. So we can give visit ampersand browser comma google.com, which we visit, which is google.com, and again we can visit to LinkedIn, or I'll give something else. I'll just copy it for fast process. So first thing, suppose I give github.com, then I'll give stackoverflow.com, something kind of that. Then we'll give back ampersand browser comma we'll give what we can give I think we can give forward ampersand browser, as we created in the function we are giving that. Then we can visit ampersand browser comma linkedin.com, visit a new page, clears forward history, which we can do that. Then easily we'll display the ampersand browser, then we can return 0 and we can end the program, and let's see the output what could be. As you can see, this code effectively simulates browser navigation with proper stack management and clear output for each operation. As you can see that visited google.com, visited github.com, visited stackoverflow.com, moved back to github.com, moved back to google.com as it came, then moved forward to github.com, then visited linkedin.com, current page linkedin.com, back history and forward history, and this is the output. Basically we are seeing that simulating browser history management using two stacks to handle the back and forward navigation. In this core concept we see that to visit a new URL and back navigation, then forward navigation. So by seeing this each part, we can see the stacks as a data structure, then we use a visit function, back function, forward function and display functions. Actually why we use stack in the sense last in first out, stack are perfect for history navigation. Since the last page visited in the first one, you need to, when going back, need that, and removes a page from the stack in big of one time, which is pop, and push adds a page to the stack in big of one time. And also in a real world analogy also, back stack and forward stack is very important. Imagine you are flipping book through a book. So basically what we are doing is, you can start on a home page and visit new page, then navigate back to the previous page, and then we can navigate forward if possible, then display the current page and history. Then these are the approach we can see. Then history management can be implemented using stack, as we know that the idea of the stack transition, moving between pages and clearly invalid paths when a new page is visited. So this is what we done in browser management. Thank you for watching this video. This is the code that browser management we got the output. So thank you everyone.